right, guys, let's get talking. There's some things that you don't have on your desk that I need to discuss before we get going. The first thing is the quiz. Now, the first side is a polynomial. You know, if you have like x squared over 2, you guys know that that's 1/2 x squared. You don't have to use the quotient rule for that, right? If you have x squared over 2, that's a half x squared, or x to the 4th over 2 would be a half x to the 4th, right, when you go to take the derivative. I mean, there's nothing wrong with using the quotient rule, but don't make that first one more complicated than it has to be. If you get irrational numbers, like if you get the square root of 3/5, just leave it, okay? Don't say the square root of 3/5 is, I don't know, 0.4, because it's not. You know, like, don't just change it into a decimal and terminate it. Just leave it in radical form. The second one, though, I wanted to mention to you is the rational. Whatever one you got, it's going to be a rational function. So there's one thing that I would like to add to the second one. If you could just fit a line, maybe like right above where it says x-intercepts. If you could just put in for question number 2, domain with a slash. For the second question, the rational function, polynomial, the domain's all reals. But, you know, with the rational function, like we talked about yesterday, it's important to know the domain, because you can't have a max, min, or point of inflection at an x value that's not in the domain. So this is kind of just to make sure you get that part right. So if you could just add that in, that would be great. You guys take a look at it yet? Yeah. Did you try the polynomial one? If you get weird answers, and don't forget, you have a calculator to check. I mean, just graphing what's on the calculator isn't going to get you points, but it'll help you find your mistakes, right? So I do want to see that first derivative, get the critical values. I want to see a first derivative sign chart and a second derivative sign chart, etc. Okay, extra help I told you would be Wednesday. That's tomorrow. Did I give any of you guys the review sheet yesterday? No? Okay, let me give you that. You do have it. So I'll give just 2 for this rough. Actually, let me pause this. This is boring. Okay, on the review sheet, you know, the first one is straightforward. You know, it's where's the function concave up, down. You know, you're going to make a sign chart for your first and second derivative and do a little graph. But if you look at number 2 on the review sheet, directions, what I wanted got cut off. And so I have to, all it says, if you turn the page, it says where these values occur. That's all you see. So for question 2, for both A and B, what you have to do is, it says find the absolute maximum and the absolute minimum values of the given function on the indicated closed interval. State where these values occur. So what I'm looking for is, like, there's an absolute max of 5 at x equals 2, and there's an absolute min of 0 at x equals 4 and 7, or whatever. But I want to know the absolute max and the absolute min on the closed interval. So remember, you got to get the y-coordinates at the endpoints and at the critical values. And the greatest is the absolute max, and the least is the absolute min. But yeah, those directions were missing. Okay. Questions? Anything you ran into when you were looking at this? Any questions? Okay. So today is actually so kind of fun and light, I think. We're going to start out with this little chart. This chart is going to be your key to success. If you understand this and can remember it, this is going to make your life so much easier in here. The first few blocks, I've given you the sign of the first derivative. And from the sign of the first derivative, you can't say anything about the second derivative. That's why it's kind of darkened out here. But you can tell me about the function. So if the first derivative is positive, what can you tell me about the function? Nice, increasing. If the first derivative is negative, then the function is good. If the first derivative changes from positive to negative, then the function is a relative max. Nice. And if the first derivative changes from negative to positive, the function has a relative min. Excellent. Okay. Now we're just going to shift it over a little bit. Now I've given you the signs of the second derivative. And remember, the second derivative is simply the derivative of the first derivative. So when the second derivative is positive, the first derivative is increasing. We just did that. If the second derivative is negative, then the first derivative is. If the second derivative changes from positive to negative, then the first derivative has a max. And if the second derivative changes from negative to positive, then the first derivative has a. Very good. Now, not only can I tell you what's going on with the first derivative, you guys understand what the second derivative sign tells you about the actual function. So if the second derivative is positive, that means the first derivative is increasing and the function is concave up, right? If one of these is true, they're all true. If the second derivative is negative because the slope, the first derivative is decreasing, the function is concave down, down, up, up. If the second derivative is changing from positive to negative, what's going on with the actual function? Point of inflection, because the second derivative, so that's telling you that your graph is concave up and then concave down, right? We call that a point of inflection. And if the second derivative is changing from negative to positive, you still have a point of inflection. It just means your graph's concave down and then up. The min is from where the first derivative, like you could have a min if the first derivative is 0 and the second derivative is positive. Like if I happen to know this is, but if all you know is the second derivative is positive, all you know is that the function is concave up. You don't know where on here you are. Okay. I need some point of inflection again. Inflection. So it doesn't matter. If there's a sign change in the second derivative, the function has a point of inflection. It doesn't matter if the second derivative is going positive to negative or negative to positive. With the first derivative, it matters, right? Whether you have a max or a min. If the first derivative changes sign, that order matters. The function of max or min, depending upon which one. All right. Who thinks they understand this little chart? You think so? Ready to have fun with it? All right. This is cool if you don't look at the graph first. If you look at the graph first, your eyes are going to drag you into like a pit, and it's going to be very dangerous. So you have to first think about the chart. I'll show you what I'm talking about. Time for crazy fun. You're going to be given a graph, all right? In this case, in A, it's a graph of the first derivative, okay? We're not going to look at it yet. All we have to know is we have a graph of the first derivative. The first question is, where is the function increasing? Before you look at the graph, if a function's increasing, what does that mean about the first derivative? Everyone see it's positive? So before I even look at it, because I don't want to see where this is increasing. That's not the question. The function is increasing where the first derivative is positive. Now look at the graph and tell me where the first derivative is positive, on what intervals. Yes, Karen. From A to C, E to infinity. Good. The answer is from A to C, and then from E to infinity. See? Crazy fun. So, but what I don't want you to do, because there's always like at least 5 kids in the classroom, who will tell me where this is increasing. If you just say, you look at the question, increasing, and then you look at this, you're going to, I'm never going to ask you where is the graph that I give you. I'm never going to ask you a question about what you're looking at. That's why you have to take a second and first interpret in terms of the graph you're given. So part B says, where is the function decreasing? What does that mean about the first derivative? Negative, right? Okay, now you can look at the graph. Where's the first derivative negative? C to E, I agree with that. And where else? Negative infinity to A, negative infinity to A, and then again you said from C to E, right? Yeah. Nice. Okay, next one. Where does the function have a point of inflection? Function has a point of inflection when the first derivative has a max or min. Now I'm ready to look at it. Let me actually write that first. So f prime has max or min. Oh, that wasn't real. Okay. Because, you know, we know a point of inflection is when the second derivative changes sign. But that's the slope of the first derivative, so we want the slope to change sign. So, okay then. X equals B and X equals, as in, well, okay, yeah, for some reason I was hearing E. So B and at D. Because this is the first derivative, so the second derivative is changing from positive to negative. Second derivative is changing sign at B and at D. So X equals B, X equals D. You guys see that back there? Okay. Where is the second derivative positive? What does that mean about the first derivative? Increasing. So we're looking where f prime is increasing. Okay, now we're allowed to look at the graph. Negative infinity to B. Okay, yeah, I agree with that. So negative infinity to B. Is that right, guys? D to infinity? Yeah? Oh, you say so. Where is the second derivative negative? What does that mean about the first derivative? All right, John. It's decreasing. So we're looking where f prime is decreasing. I'm just making this note here, so that's what to look for. You said from B to D? Yeah, that's right. This one says, all right, next one says, where does f of x have relative extrema? What does that mean about the first derivative? Function has relative max or min when the first derivative, positive to negative, negative to positive, changes sign, right? A function's going to have a max when the first derivative goes positive to negative, or a min when the first derivative goes from negative to positive. So you're looking to see where f prime changes sign. Now, if you're looking at a graph and you want to see where it changes sign, you're looking where it crosses the x-axis. I got something different, something new and exciting. Sorry, you're still excited. You don't want to be new and exciting? No, you're definitely not new and exciting. No, you're not really new either. Jan, she did volunteer before, but yeah. What do you think? A. Yeah, it's a C. X equals A, X equals C, X equals E. Very good. Change of sign each of these. Now, which of these is a min and which is a max? Okay. At A, it's a min because it's going from negative to positive. You got to read left to right. Okay. What about C? Mm-hmm. D? Yeah, cool. So, it's like a little puzzle. Ready to try next one? So I don't know what's coming up next. This first one, we had a graph of f prime. I don't know what's going to happen. Oh, that's just that. Oh, no, look at this one. In B, we're looking at f of x, the actual function. Woohoo! I wonder if I'm going to ask you questions about f of x. Nope. That would be boring. And we can just look at a graph and say where it's going up or down. Oh, we want to interpret it. All right. So every time you go to answer this, you have to first relate it to f of x. So the first question, where is the first derivative increasing? All right, Audrey. Yes, because you might say, okay, that means the second derivative is positive, which means the function is concave up. See that reasoning? First derivative is increasing, which means the second derivative is positive, which means the function is concave up. And you always got to get it back to what you're looking at. So we're looking to see where it's concave up. Oh boy, where it looks like a cup. That's right. Yeah, d to infinity. Because look, if you follow along, sad, concave down, concave down, concave down, still sad, sad, concave down, concave down. You get to d, oh, things are looking up. Then from d to infinity, it's concave up. Good one. All right, we're relating this back to the function. Where is the first derivative decreasing? I just got you. Somebody else. Somebody else. Oh, look, I had Jess doesn't raise her hand like everyone else does. All right, we're going to give you this one, but then next time. All right, so what are you saying? When the function is concave down, okay. Where is this? I'm going to next time. You want to finish this one up? Okay, I do agree it is concave down from C to D. Is that it? Oh, from B to C. So from, how about B to D? Okay. Yeah. So from negative infinity to B, and then from B to D. I'm splitting it there. Yeah. So negative infinity to B, and then from B to D. It's exciting. Brian, do you want to answer this one? Do you think? Yeah? Okay, so it says, where does f prime fail to exist? Well, the derivative fails to exist when the function, yes, corner cusp or vertical tangent. So when f has a, I'm just going to draw a picture, corner cusp or vertical tangent. Yeah, close. It was. I don't. Kids at home are like, what? I don't know that. All right, yeah. So if the function has a corner cusp or a vertical tangent, the derivative doesn't exist. So where would that be? At x equals b. Nice. All right, it's getting exciting. Where is the first derivative positive? More people want to jump in this game. First derivative is positive when the function increases, right? So we're looking where f increases. Now we can look at the graph. B to C. Okay, yeah, no, I agree with B to C. B to C and e to infinity. Okay. The next one, I want somebody who hasn't spoken yet today to answer. So if you've already spoken today, you got to shut it. Oh, Emily, you have an idea? All right, we haven't heard from you. This would be great. Wait, what's it say? So where's the first derivative negative? First derivative is negative when the function is decreasing. Let me just write that down. Okay. Negative infinity to B, and then from C to E. Yeehaw. Yes, it is. Remember, you can have a max or a min where the derivative is 0 or doesn't exist. So that is stuff. Okay, where does the first derivative change sign? The first derivative changes sign when f. All right, I'm going to, Audrey, yeah. Correct. The first derivative changes sign when the function f has a max or a min. Max or min. And where would that be? B, C, and E. So x equals B, x equals C, and x equals E. This is the last one here. Oh, no, it's not the last one. I'm going on to H. Where does the second derivative change sign? Second derivative changes sign when the function has a point of inflection. You know that, right? You knew it. F has a PI. Now we got to look. Point of inflection is a point where the graph changes from concave up to down or vice versa. Is there any point, right, Riley, at D? See, it's concave down, and then it's concave up. So x equals D. D is not a point of inflection because the second derivative, because it's concave down on both sides, so that would not be, doesn't change concavity there. Where is the second derivative positive? Second derivative is positive when the function is concave up. Well, second derivative is positive. See, if I said the first derivative is positive, that would be increasing. Second derivative is positive when the function is concave up. Where would that be? Oh, it's the same as the first question. Because there are different ways. Because before I said, where's the first derivative increasing? That was the same question. So it's d to infinity. Saying where's the first derivative increasing is just like saying where's the second derivative positive. What do you think about that? Now we have one more, but I want you guys, I'm going to give you like 5 minutes. 5 minutes. Try it. You can check with people around you, but try it first. That. Thanks. Oh no, we're not pausing. We're going. All right, now we're looking at a graph for the second derivative, and they want to know where's the first derivative, where is the first derivative increasing? Where the second derivative is positive. So now you know to look at the graph, and your answer is C to E. Did you get that? Yeah, I'm not going to tell me if you didn't. Where is the first derivative decreasing when the second derivative is negative? Okay, and where is that second derivative negative? All right. Yeah, if you want to break it up at A, you can, but it doesn't matter if you want to include it in there. I'm kind of out of room, so I guess I'll go right over it. Negative infinity to C, and then E to infinity. Where does the function have points of inflection when the second derivative changes sign? All right, so where does this change sign? Nice. X equals C, X equals C. Where is the function concave up? A function's concave up when the second derivative is positive. Oh, same as A, right? I'm just writing same as A. You see that, guys? When we answer where is the first derivative increasing, that's the same as where is the function concave up. Oh. Where is the function concave down? That's when the second derivative is negative. Did we answer this one? Same as B. You need to do that again. Where does the first derivative have relative extrema? First derivative is relative extrema when the second derivative changes sign. Technically, we did answer that part. We said it's C and E. Yeah, we just got to give it a type. Correct. We just have to identify the type. So at C, would F prime have a max or a min? Right, because it's going from negative to positive. And at E, you guys are good at this. So what you should do when you're in other classes and you're bored, you see if you can make that chart. It's really not bad to do. If you can do that without looking, It's great. I think that's what I had for a summary. Did I even put that? Like if you were able to do it on your own, something you might want to try later. So I mean, I'll let you try to do it. But that's what I'll do. All right, let me stop.